In this section, we'll learn a few basics about map reading. We'll also talk about how to understand map directions, coordinate systems, topography, contour lines, scales, and geo-referenced digital maps. All planters should have a basic understanding of maps and cartography. One of the benefits of becoming a tree planter is that you'll learn a lot about the world around you, including things like being able to tell directions without a compass. Let's start with the very basics. On most maps, all the writing is oriented the same way, so you can determine a top and a bottom to the map. If the map doesn't indicate otherwise, the top of the map is always north. This is the case in probably 99% of maps. Occasionally, for some odd reason, north will face a different direction, but if it does, there should be a little compass rose symbol or arrow on the map that points to north. Most maps that planters use in British Columbia will also have coordinates on them. There are literally thousands of different coordinate systems in place throughout the world. Some of them were created centuries ago by early explorers and surveyors, and it's safe to say that most are extremely confusing. Within BC, you'll normally just encounter one of the most well-known systems used today, a traditional latitude and longitude system. The latitude and longitude coordinates will be in northings and westings when you refer to coordinates within British Columbia. Northings, or the distance north of the equator, range from about 49 degrees at the bottom of BC to about 60 degrees at the top of the province. These are also known as the latitude. Westings range from approximately 114 to 140 degrees, with the lower numbers on the east side bordering Alberta. These are known as the longitude. If you have problems with respect to latitude and longitude, in terms of remembering which is which, think of the word flatitude instead of latitude. Latitude lines are flat lines rather than vertical when you look at a standard map. If you're ever using software or a GIS system that doesn't allow you to type in the letters N or W to represent northing and westing, use positive numbers in BC for the northings and use negative numbers in BC for the westings. The number representing the latitude always comes first before the number for the longitude. If you get a block map, sometimes it will display the coordinates on the sides of the map in a scale. As mentioned, the latitude is the distance above or below the equator, hence the reason why latitudes are always north in British Columbia. That's why the latitudes run up and down the sides of a map, even though a line of latitude is flat, running from left to right on a normal map. The longitude is the distance to the east or west of the prime meridian that runs north-south down through England, hence why longitudes are always west in British Columbia. That's why lines of longitude are vertical and the longitude numbers always run along the top or bottom of a map. In addition to the possibility of seeing latitudes and longitudes listed on the sides of your map, there may be a single point coordinate, latitude and longitude, listed somewhere in the map's key. This is probably for a point in the very center of the map, although occasionally it will refer to a random point somewhere on the map where a surveyor decided to pick what's known as a tie point to start plots or something similar. The Global Positioning Satellite System, also known as GPS, is a network of approximately 32 satellites that are operated by the US government. If you're at any point on Earth with a GPS device that can see 3 satellites, you'll be able to determine your exact position in terms of latitude and longitude. Add a 4th satellite, and you should also be able to get your elevation above sea level. That's a bit of a simplification, but it's good enough for our purposes. GPS coordinates are typically listed in degrees, minutes, and seconds. These refer to units of arc, or distance on the surface of the Earth. An arc degree covers a very large amount of distance. The exact distance depends on where you're located on Earth, but an arc degree can sometimes be as large as 65 kilometers wide near the equator, although the distance gets smaller if you're further north. An arc minute is smaller, maybe around a kilometer wide, depending on your location. An arc second is a pretty narrow range, only maybe around 20 to 30 meters wide, although again, this distance depends on your exact location. There are 60 arc seconds in an arc minute, and 60 arc minutes in an arc degree, just like in timekeeping. There are 360 arc degrees to cover the entire surface of the Earth, just like there are 360 degrees in a circle. A lot of the time, people just drop the arc prefix when they're talking about GPS coordinates, and just use the terms minutes, degrees, or seconds. Sometimes the written format of a GPS coordinate is written using specific symbols for degrees, minutes, and seconds. Degrees are symbolized by a small superscripted circle. Minutes are symbolized by an apostrophe. Seconds are symbolized by a quotation mark symbol. So for example, 54 degrees, 36 minutes, and 30 seconds would be listed as displayed on the screen. At other times, decimal points will be used for either just the seconds or sometimes for the minutes and seconds. In this example, if just the seconds were converted to decimal, the reading would be 54 degrees and 36.5 minutes. That's because 30 seconds is half, or 0.5 of a minute. If the minutes were also converted to decimal, the reading would be 54.65 degrees. That's because 36 minutes is 0.6 of a degree. If you have a GPS device, you can go into the settings and pick the display format that you want to use. Your map may have a lot of curvy lines drawn all over it. These are called contour lines. This means that the map is a topographic map, or one that identifies the topography of the area being mapped. The best part about a contour map, or topo map, is that it lets you understand the hills and valleys on a block, because the contour lines indicate the elevations throughout the block. Each contour line represents a specific elevation, say perhaps 1,380 meters. Contour lines are usually spaced 10 meters or 20 meters apart on a block map, or perhaps 20 meters to 100 meters apart on a larger regional map. The closer the lines are together, the steeper the slope. If your map doesn't have contour lines, but it has streams or creeks identified, there's a good chance that you can figure out a rough idea of the hills and valleys on your own. Streams and creeks are usually identified in blue. Look for a blue line and follow that line to where it ends. If the line just stops suddenly, that's the highest part of the stream. Water flows downhill, so follow the creek away from the starting point where the stream officially begins, and you'll see where the block gets lower and lower in elevation. Perhaps the stream or creek will end in a blue pond or join another larger stream. Sometimes you can also guess approximate elevations on a map just by looking at the roads. The reason for this is because in hill country, the odds are slightly higher that the roads on the block will generally be going uphill rather than downhill. Of course, it is possible that roads can go downhill upon entering a block, but that probably happens less than 1/3 of the time, whereas more than 2/3 of the time, the roads are either flat or go uphill. The reason for this is quite simple. Logging companies like to harvest the easiest wood first, closest to the towns and mills. The easier wood near the valley bottoms was probably harvested years ago, and the logging companies are now making their way further and further up into the steeper ground. Also, it's easiest to build main roads along the valley bottoms and then have branches going up into the blocks in the hills. This method certainly is not foolproof, but if you have to guess, you can sometimes increase your odds of guessing correctly to be slightly better than just 50-50. Most maps have a small scale on them. This will be a number expressed as a ratio. On a map showing a small area, such as a single block, the ratio is often 1 to 5,000, or 1 to 10,000, or, for a very large block, maybe 1 to 20,000. On a larger area map, which shows a larger region of many blocks, the scale might be 1 to 30,000, or even 1 to 100,000 or larger. This scale shows a multiplier to indicate how much real distance is covered by each part of the map. You multiply the distance on the map by the large number in the ratio to find the real-world distance. Usually, we think in terms of centimeters on the map. Therefore, if you were to have a map with a ratio of 1 to 5,000, then 1 centimeter on the map represents 5,000 centimeters in the bush. 10 centimeters on the map would be 10 times 5,000, or 50,000 centimeters in the real world. Now obviously, trying to measure real-world distances in centimeters is an exercise in futility. So, you can convert these numbers to meters simply by dividing by 100, since there are 100 centimeters in a meter. In other words, in the example where 1 centimeter gave us 5,000 centimeters, that's equivalent to 50 meters. In the second example of 10 centimeters on the map, that becomes 50,000 centimeters, or 500 meters in the bush. These scales are really cool because they can help a planter or a foreman plan for how many trees need to go into an area. Let's say that you're looking at a map with your foreman and you've identified exactly where your cache is located on the road on the map. Let's say that you're looking at filling a big pocket. You can get a ruler out and measure from your cache to the back of the pocket on the map. Let's assume in this case that it's 4 centimeters on the map from your cache to the back of your pocket, and let's assume that the scale on the map is 1 to 10,000. This means that the 4 centimeters on the map represents 400 meters in real-world distance. Let's also assume that your average spacing on this block needs to be 2.5 meters between trees. To go 400 meters to the back of your pocket, you need to bag up with 160 trees. You get this number by taking the distance and dividing your average spacing between trees, or 400 meters total divided by 2.5 meters between trees. But you'll also want to be able to plant back to your cache instead of dead walking. So you should take a minimum of about 320 trees in order to plant into the back and then work your way back to your cache. If you can carry even more than 320 trees in your bags, that's even better, because you can plant the extras at the back before you turn around and plant back to your cache. One of the biggest revolutions in the planting industry since the introduction of LFH planting in the mid-1990s has been the introduction of digital maps, and in particular, georeferencing. When a digital map is georeferenced, this means that it has actual GPS location metadata embedded within the file. Certain apps can load those maps into your mobile device and correlate the map with the actual current location of your mobile device based on the GPS receiver in the device. If the app determines that you're actually on the map, it will display your exact location on the map with a little marker indicating where you're located, perhaps with a blue dot or something similar. As you move around the block with your mobile device, your location indicator moves around on the map. It's just like using Google Maps or other similar services, except that these geo-referenced PDFs are generated by your silviculture forester and can show your planting blocks in great detail. Naturally, Google Maps focuses on towns and cities and government-maintained roads, so it usually isn't any good on remote planting blocks. At the moment, an app called Avenza PDF Maps seems to be the most popular way to work with geo-referenced maps. Another bonus of apps that use geo-referenced maps is that you can do the same sort of distance calculations as what I explained in the example with the ruler a few minutes ago. You just tap two spots on the map, presumably your cache and the back of your piece, and the app tells you the exact distance between the 2 points. You can also outline an area, such as your entire piece, and the app will do an area calculation for you. Let's say that your area calculation shows that your piece is approximately 1.2 hectares in size. If you're aiming for 2,000 stems per hectare, and you do a good job with your density, you can assume that your 1.2 hectare piece should hold approximately 2,400 trees. Being able to make calculations like this really helps with planning.
Understanding maps and coordinate systems can be far more confusing than what we've explained here because the topic can be incredibly complex. However, if you master the basics we've explained here, you'll understand all you need to know to be comfortable with looking at a map and trying to figure out where you are. It's important that your foreman should always leave a map on the dashboard of the truck, so if there's an emergency and the foreman is incapacitated, the planters will be able to figure out exactly where they are and relay that information to outside help. If there isn't one, ask your foreman to leave one there for emergencies, with appropriate contact information to reach outside help. Most companies require that each crew have a written emergency response plan with all this information and with instructions on what to do in an emergency. As a planter, you should always know the number of the block that you're working on. A great idea is for the foreman to use a dry erase marker to write the block number on the rearview mirror of each truck every morning. You should also be able to find the block number on the map on the dashboard.
If you're trying to learn more about the tree planting industry in Canada, then a book called Step by Step, A Tree Planter's Handbook is going to be your #1 source for information. All of the information in these videos came from Step by Step, although the book contains about 3 times as much information as the videos do. Let's take a quick look at what's inside. Why do we plant trees? Health. Working safely and hazards, vehicles and transportation, camp life and other lodging, map reading, nature and the environment, basic silviculture knowledge, stock handling, common coniferous trees, prescriptions and planning, planting equipment, camping gear and clothing, planting a seedling, meeting quality requirements, density and excess, site preparation, additional planting techniques, maximizing productivity, planting throughout Canada, applying for a job, working with helicopters, coastal planting, logging and harvesting, other silviculture work. And there's more. The few hundred pages that you just saw represent only a bit more than a third of the full book. To order a copy today, search for it on Amazon or visit replant.ca/step-by-step.